Yo, what's up, everybody? It's not even everybody. Nobody's on yet. Oh, man. It's been a ride with this thing. I'm going to watch this video later. I'll start now, I guess. So, Ender 3 NG V1.2 version 1.2. That's what we were just building over the last couple months. I originally said I wanted it to take me a week and a half, and you can build it in a week and a half. It's for me and everything else we got going on, it always takes a little bit longer, but not a little bit, a lot of it longer. But we finally got it done. We got the build done. Off camera, I did the enclosure. You know, I'll put that up in a different video, like more, I don't know if it's going to be tutorial style, but more of a, you know, production type thing. It wasn't live, but we did get the enclosure up. I don't know if you can see it right now, but let's go in the shop. That's basically the printer right there. We're going to calibrate it today. We're going to start off with a temperature tower. We're going to do a retraction tower. We are going to do a flow rate test, and after that I want to print the Ender NG calibration cube. So right now, let's start off with that. Let's see. Give you guys my screen. We're gonna do everything from Creality print and I don't know if you guys can see me now. All right, so I already created a printer profile. I did this profile built off of the K1, so you know, we can go in there real quick. I'll show you. Select it, edit it. We're going to advanced. Right now, this is the way I have it set up. You use relative E distance. That might be an issue that I'm having. You see some K1. Use the same thing. See my 5S1 is doing the same thing. All right, so yeah, I have been printing on this thing. I'm not gonna lie. I've been trying to calibrate it, so we definitely gonna go through it together. All right, nozzle volume. So this is all built off of the K1. We're using a 0.4 nozzle, brass nozzle. It has auxiliary fans. I don't have an air filtration system in there. I do have machine LED lights. Machine platform motion enabled. Okay. This is the G code that I use to start an NG code on my. I gotta replace this. That's why I didn't end right when I printed something last night. So I got the M190 as the bed temp. So it's gonna set the bed temp for the initial layer height of whatever print I'm sending. It's gonna do that first, then it's gonna home the axis. The only reason I do that is because I'm using beacon contact for my Z offset, so it's automatically offsetting the Z. You'll see that when it starts up as well. So I need the print bed to be whatever expansion it's going to have from the heat. I need it to be in there. So it's going to do the contact on the G28 home axis. That's a part of the firmware and Klipper and the printer config file. Then next we got the nozzle heating up, and it's going to heat up and wait to whatever the print temperature is for the print. And then I have a macro in my Klipper settings to wipe the nozzle and clean the nozzle. But I'm basically just going to do, once it heats up, it's going to do a nozzle wipe. Then it's going to do the bed mesh, save the bed mesh. Then it's going to do the smart part was because I had another nozzle heat in M109, and it was just slowing down the printer completely. So I took that out, and you know, smart part's still there. It just basically goes there and goes back to the wipe nozzle. So whatever leaked out from it being at print temp, the nozzle wipes it again. It goes to do a line purge, and then it starts to print. Now this NG code isn't what I want. This is the original one I had. I changed it because this one was based off the K1 Max, and I wanted it based off of the K1. So let me take all of this NG code and put it in the new one. All right. So this is what it's going to do when it ends. Basically, stop, drop, move the nozzle head away, drop the print bed, and start to cool down. Turn off all motors and functions. So that's cool. We're going to save that. All right, bet. So we're going to keep this profile. This is what I have in there. There's no multi-material. There's only one right now. The extruder. It's at 0.4 nozzle. I do want to change my retraction. Put this back. I'm gonna put this at about. Put it back at 8. Matter of fact, let me put this. Let me put that at 8. I'm gonna put my retraction speed to 35. Retraction and detraction. I'm gonna keep my detraction at 30. I want it to come back pretty quick. All right. So retract on layer change. Now wipe nozzle, wipe distance, retract amount before swipe, yada yada yada. All this is based off the K1. Here's my motion. So speed limitations. It's on the X, Y, and Z. Limitations. I got my acceleration. Let's go into acceleration. So these are my accelerations. I got them at 20,000. When I did my initial input shaper test, it told me to not do any like heavy smoothing. I would have to be under 18,000, but we're going to test it. So 20,000 on the Z is 500. Maximum acceleration in the extruder is 5,000. You get it. So let's get out of here. I didn't make any changes, right? I'm gonna save if I did. All right, so Creality Print, you know, just like any other slicer, it has calibrations that you can use. Definitely going to use them right now. Right now I have a standard, I have a standard K1 setting. I'm gonna go into calibrations. They got calibrations at the top. We're gonna do a temperature test. All right, so this is going to be regular PLA. We're going to start at, let's start at 230. I don't think PLA needs to be hotter than that, no matter how fast you're going. We're going to end at 190. It's going to go up by 5 each time, so it's going to start at, go down by 5 each time, so it's going to start at 230. It's going to go to 225, 220. 215, 210, all the way down to 190. All right, the build plate is going to be at 50 degrees Celsius. Okay, so now it's going to create it. All right, so this is our temp tower. As you can see, starts at 30, goes up 25, 10 at a time. So what we're gonna do with this, cause it's not that right. And I gotta, my computer slows down when it's in preview mode. Let me go into prepare. I can't do that. All right, man. So I gotta go for preview mode, but it slows my computer down. Do this again. All right. gonna export this. Y'all can see my files, I don't care. Really, I do care, but. All right, let's go into pressure events. No, this is a pressure event. Temp tower. See how slow it's moving? All right. So we're gonna do temp. All right, yeah, I was on mute. How long was I on mute for? Yeah, I'll get you my config for my Cobra Max. Everybody there, how long? Oh, since I came back from the print review, and when I switched to the printer, it sounds. I'm gonna switch again. Let me know if it sounds funny. Still sound like something. I'm back now. Does it sound like it still sound like the mics? Something's wrong with the mic in there? All right, cool. I don't know what that was. All right, so yeah, let me go back to where I was at. All right, cool. Make sure my mic is still on, man. You switch these. Sometimes when you switch scenes with these switchers, it turns your mic off. Make sure. Yeah, my mic's still on. All right, cool. All right, okay, so calibration testing. You got your pressure advance, BFA. You're struggling with increasing acceleration, print speed. Oh, okay. Now, here's one thing, Dawood. On my Cobra Max, stuff that I've been learning from this printer, I gotta go back and do to the Cobra Max. Like, I definitely have to do some pressure advance testing, and that's probably where your acceleration and print speed you're having issues with. You have to calibrate that. So, you know, with so much weight in a Cobra Max print bed, it's real tough getting speed. So you have to calibrate the pressure advance. So, you know, you would do a pressure advance test. Matter of fact, let's go here. It's crazy, it popped up because I was looking at it. So you will go here, if you're in Klipper, what you're going to do is, and I'll explain this a little later too, you're going to download this STL right here. Where is it at? They have the link in here. It's right here. So you'll go here to this page. This is the, I don't know if I can put it in the description right now. I don't know if I can edit that. But this is it right here, the clipper3d.com, pressure_advance.html. And the y-axis motor is skipping. Either it's the motor or it's the you have your run current too high or too low. Now touch your motor. If it's too hot, then you got your current too high. If it's cool in the skipper, you got it too low. Okay. Let me see if I have it in here. I might have it on the other computer, my Klipper. Got too many files on there. I'll look at it a little later, and if I find it, I'll send you a link to a GitHub page where I'll download it and put a copy of it. All right, so the printer started. So we'll go back to this calibration stuff later, but I am curious. Pretty sure that has to do with acceleration. Vertical fine artifacts. That's something I'm gonna have to do too. So I guess with like layer lines and Z jamming and stuff, that's what the BFA is for. Okay, so here's the printer right here. So what we're gonna do, we're gonna go, and I'll let you see my config before we get started. So I got all this stuff in here. I got a clean nozzle macro. I got a wipe nozzle macro. Of course, because I'm using Temp for adaptive bed mesh, I got exclude objects in there. I got one that I created with all my macros called Essential Macros. Here's my camp settings. And this printer does this from time to time. I don't know why. Then after it runs for a minute, it allows me just to consistently be in it. But all right. So these are all my included macros. This is the beacon probe, 3D probe, and since I have everything connected UART, this is my serial. I don't have a USB serial. It's connected through UART on the motherboard. Got my Y, my X and Y offset. It's supposed to be the way it's supposed to be. How far the beacon is actually from the nozzle. It's 0 from the X-axis, but from the Y, it's really like negative 23.5. But when I do that, it offsets it. So I just left it 0, 0. It seems like it's printing fine. It runs 2 mesh, so it goes one direction, comes back and does the other. Right, my max temperature for the contact is 180 degrees Celsius. So if the nozzle is more than 180 degrees Celsius, it won't do a contact. All right. Of course, since I'm running with a 230 millimeter by 230 millimeter, my mid home position point is 115 by 115 on the X and Y axis. It's Z hops 3 mils when it does the contact. The Z hop speed is 10 millimeters per second. Let me see. Home axis speed 300. Home method is contact. Basically saying it's going to use the nozzle to home. Home method when home is proximity. That's something within. We can go through that if you guys want. That's something within contact. Unhomed auto calibrate unhomed. So I don't. That's not when I looked into the calibrations on the website. They said it had to be unhomed if I wanted to touch the nozzles. Other ways you could do it, but it got extremely complex. Contact sensitivity is 3. That's not the highest sensitivity. That's the lowest sensitivity. The Ender 3NG is very noisy, so that can kind of the vibrations from the noise can mess with the contact, so it'll start thinking it's hitting something just from the vibration of the stepper motors and the belts and stuff like that. So yeah, so I got it on 3 at the most tolerable level. Of course, I have here we go with this. It'll do this from time to time, people. I'm gonna try and run down this as quick as possible so we can get to this calibration test. Matter of fact, we can get into here while it's actually printing. So let's start printing first. Once this thing stops, and I don't know if this is a Klipper thing. A lot of the printers, when I rebuild them and put the new firmware and stuff on there and Klipper firmware, it tends to do this with the Raspberry. I don't know if it's the Raspberry Pi or something else. But let's go to File. We're gonna go Upload Files. We're in Pressure Advance already. Didn't I name that thing PA Live? Oh no, it's a tip tower. We was just talking about Pressure Advance. Okay. All right, we're doing the temp tower. So files, temp tower, temp live, upload. Could be my internet too, people. Could very well be my internet too. I'm live. I'm using a lot of the whatever it's called. It's my mind went blank. All right, go back to files, files, temp tower, temp live, upload. There we go. Boom, it's in there. So now, what I'm gonna do, I'm going to go to the shop. All right, you guys should be seeing the printer. Send it to print. So right now, it's printing. It's gonna start printing. So let me see what you guys are seeing. I gotta see it in the timing that you're seeing. Extreme. All right, so right now it's basically heating up. So let's put this over here. Can't really see you seeing the screen, but see my arrow on it behind the actual printer. You know, it's got the setup. If you're used to Klipper and all that, you got this. You know what you're looking at. T, what's up, T? Everything's cool. We about to try and get this thing calibrated, man. I'm not gonna lie. I've been trying to do this without you people, and I don't know what's going on. We'll do some measurements. I'm having trouble printing benchies, and it looks like it's a communication thing from the slicer. Oh, let me see. Yeah, it looks like it's a communication thing from whatever sliced into the printer. So, you know, like even the infill just looks crazy. It doesn't look like a benchy at all. So if you can see right now, it's almost there. It's about to start once it gets to 49. So since it hasn't been started, it's going to do the contact. So that's what it's doing now. That build plate is crooked too. Super crooked. I gotta adjust the knobs. So it does 3 touches. If it has 3 consistent touches, it saves the Z offset, and it doesn't until you know restart the firmware. It keeps that in there. So right now, let's go back. So right now what it's going to do is heat up to 230. You're going to see, of course, some drip from the nozzle. It's going to do a wipe on the back brush, come back scan in one direction on a Y and X. So now it's doing its wipe. Now it's going to scan with the probe. It's campus adapted bed mesh, so it just did the section that it's going to print in. Wipes again, and then it gets started. That's the purge line. Clean off the nozzle. And remember, it's going to start at 230. And what I love about that beacon, man, it's a little close. It's a little too close to the build plate, but it comes out pretty good. Nah, T. Oh, I have. Let me see. I got the box right here. So let's see. I got 16 gigs of RAM in there. I usually always always get the 16 gigs or none. I'm lying to you. I don't always get the 16 gigs. I got, let me go back here. I got one right here that's unopened. That's 4 gigs. I don't know if you can see it. That's 4 gigs. The one that's in the actual Ender and G, that's this one. It is 16 gigs of RAM. Yeah, T, man, you're the man. How you can't get Camp to work? Matter of fact, let's go into let's go while this is printing. Go to which screen? Design. Where you at? All right. So while it's printing, I'm gonna go into the config file and see all it is with Camp. See if I can. It's a few steps though, T. You definitely have to go into Moonraker. Where's Moonraker? All right. So you have to go into Moonraker. And file manager, enable objects processing true. You have to add this to it. And then, you know, you add the automatic update, the update manager into it from the Camp website. So you need to put that in your Moonraker file. Once all of that stuff is in there, you know, you go online, they have to where you can run terminal, whatever you're running, maybe putty, and you terminal into your Raspberry Pi. Terminal into your Raspberry Pi. Terminal into your Raspberry Pi. You gotta install the Camp settings, and this is where it tells you what to install in your Moonraker. You have to put the update manager, but also, it says it on here. Oh yeah, and the file manager, enable object processing. Then once you get into your config file, you have to include Camp settings. And then what I found is you got to take all of the. Let's get into it. All right. You have to take everything out of this Camp folder that's in the Camp folder. I thought you could just use the Camp folder, but I had to take everything that's in this Camp folder and put it into the home file of the Pi. So all of that stuff, adaptive bed mesh, smart part, Voron purge. I don't use the Voron purge. So I had to take all of that stuff and insert it into the actual home file in order for the config file to pick it up, because once it stayed in the Camp file, it just wouldn't recognize it. Yeah, and it might have been exactly what I'm saying to you. Like this, when I first did it, it wasn't working at all. So I had to take all of the files out of the Camp file and put them directly into the PI home file. So I know it's a headache. Like one day I was sitting here for hours, and you know, maybe somebody knows a better way to do it, or you don't actually have to do that. But I thought initially that you could just put the Camp, you know, include the Camp settings, and everything would just pop up. The macros would just pop up on the macro page, but it doesn't even work like that. They're not macros per se. I don't even see them on here. So these are all my macros in my essential macros file. So this thing, when I first started printing with it, and it will fly, like it flies, but it is not moving that way right now because I have, if you can see, I don't know if you guys are going to be able to see it. Maybe I'll keep it at the bottom so you can see it. I have the pressure advance turned on. I actually calibrated my pressure advance. I'm sorry I didn't do it with you guys. I'll explain how to do it. So it's actually using pressure advance right now. That's the reason why it's not flying. When it accelerates, it flies, but when it prints, it's being careful of the edges. It slowed it down a lot. Like, you know what I'm saying? And the reason I don't know, what's the issue with it, because like I told you, I had printed some things. I tried to print a benchy, and right between the benchy, if you guys can look, and that's why I said if you look at this benchy right here, I'm gonna try and focus in on this so you can see it. Like it's retraction, looks like it's under extrusion, but I did my E steps, and you know that the E steps are almost perfect, so it's not under extrusion from the E steps, and the retraction I brought down to about 4.4 millimeters distance. I don't know what that is. This is actually better since the pressure advance ran. This is actually better than what I said before it was almost connecting the two whole windows. So I'm not sure what it is. Excuse me. Let's focus on. Trying to focus on me, but it's not going to do that now. Focus on the stuff I got in the background. I use my remote so to take a picture. Anyway, the retraction distance T is set to right now on this print that's printing right now. It's set to I think I changed it to 0.8. I'm not sure. I'll go back into it so we can see it. I'm trying to fix this. Focus on me now. All right. So I'll go back into the computer and try and fix it. I mean, show you what I got. All right. Let's see what the retraction distance is now. So the retraction is 0.8 millimeters right now. And I know that it seems like it might be too much, but that print that you just saw was 0.4. So I turned it down to half of this, and you know, in between I was getting you know, retraction. I was getting retraction artifacts going back and forth in this benchy. So I increased the length, and I slowed down the speed on the retraction and kept the detraction 30 millimeters per second. We are going to do a retraction test though. Be it too. The hot end fan is on, but maybe from the design, if you look at it, maybe from the design, it's not coming all the way out. Like you got an air pocket right here at the bottom, and it's an air pocket at the top too, but maybe it needs that fan coming straight out. So it could be heat creep. Yeah, I'm thinking that too. I might just reprint it and open it up. I might put the Jadobi logo right there. RH3D, if you watching, man, I would put the NG logo, but that's Jadobi spin right there. No, but yeah, it could be heat creeping there. Cause when I watched it print this whole benchy, and it looked like when it got to the tip of the hole right there, like it just didn't care what was happening. So I thought maybe it could have been, maybe it's something in the actual slicer that I can adjust as far as adjusting the overhang. But it was just like, it looked like it was just laying down filament, and you're right, it could not be properly pushing it out. Well, we'll see even with these temp towers, you know, how they look. There is a lot of airflow in this thing too. You see I got two side fans. And you know, for it to print as slow as it does, and that's basically restricted to the movement of the machine, I might have to turn those down. Probably cut those to 50%. Yeah, coffee got cool. Yeah, it's real good. It's real. When I did the initial test, the speed, the print speed and acceleration test, it moved real good. Nothing was sliding. It doesn't seem like anything's skipping. Yeah, everything's moving pretty cool. Looking on this benchy, I had some looks like some some inconsistent layer lines. I'm wondering if something was up with the Z, but it could definitely be that. It could be heat creep. I haven't had any clogs. But when it does its purge line, it does seem to not come out immediately. It's in Stealth Chop. Z's in Stealth Chop. Should be in Stealth Chop as well. Yeah, my dogs. There must be somebody at the door. X is in Stealth Chop. So yeah, it's really torquey. Extruder. Putting the extruder. It's in Stealth Chop as well with the threshold set to 0. You think that might be it? No? Okay, so you're saying change the spread cycle? That could definitely be it. Yeah, and that could be it. It could be reacting too torquey and skipping steps. Yeah, I might do that. You have less torque in stealth? I thought it was more. Oh yeah, no. Stealth chop, you're right. Stealth chop is to make sure the motor stay quiet. So yeah, you're right. My apologies. Spread cycle. All right, so I gotta wait for this. So the original. Now I bought an ender specifically for this. And I bought the ender used for I think like $80. Let's go into it. I'm gonna take this off 1 second just so you can see. The bill of sale. Have a configurator. I never I've seen it, but I just didn't pay attention to this. Let me see this. Oh, no, it's the configurator. Like, this is actually what I wanted to see. As far as, oh, okay. I'm gonna move this out the way for a second. So, when you go to the website, which is right here, it's rh3d.xyz. You're going to into the project, printer configuration, configurated download, and then to open this up. You got the bill of material right here. So this gives you all of the parts, everything. If you want to buy it individually, it's all here. It even gives you the link of where to get some of this stuff. Now, this does have kits, and that's what I'm looking for right now, because it's easier to price that stuff out, because the kits come with everything. Bill of material. Parts. These are the printed parts. Where are these kits? Frames, electronic, filament extruder, stepper motors, tools. There is a part that shows the kits. Oh, here we go, verified kits. So, if you go, say you do this minus the enclosure. These are motion kits, electronics, motion kit. So let's say if you went to with the electronics and motion kit, you get all of the bearings you need, the rods, the screw rods and everything. You get all of that stuff for $200. Get the hardware kits, all your screws, nuts, T-nuts, washers, heat inserts and everything, about $36. Put that together, that's $236. On top of that, it cost me $80 for the printer, $316. That's about $316. If I was to build it without the enclosure, if I wanted to put the enclosure on it, the full enclosure kit costs $159. So that's 316, somewhere around $500 to build this with the whole enclosure kit. Which you could definitely, go buy a enclosed 3D printer, especially, I know, I forgot the name of the company. I said I know, but I forgot the name of the company right now off the top of my head. They have an enclosed Core XY printer for around like $300. Like, you could definitely go buy one, but this, this was just the experience of building it from the ground up. But the total cost, I would say, Nathan, is somewhere around $500 for the enclosed printer. So that's if you go directly with the kits. Probably more, because what I forgot to mention, of course, see, with these kits, you do get the get the pulleys and all of this stuff. Absolutely, that's how I feel. What's the fun in that? And then once you're done actually building it, and you take a look at, you know, the printer, and it's actually moving, it's doing stuff, and it's like, wow, you know, I took something from nothing. Even though, you know, the directions were already created, and these instructions, these are great instructions, man. If it would, it doesn't download on here for me. On the Mac it does. Let me open this in Adobe Photoshop. Not Adobe Acrobat. I already have Acrobat. Acrobat doesn't want to play nice live. Yeah, but you know, it is the whole project is amazing. You know, it's kind of like buying a printer, but you're building it. And yeah, and on top, like I said, I'm sorry, Nathan. What I was saying on top of that was actually it's about $500 for the kit. The old Ender 3. I use the Ender 3, not the Ender 3 Pro. Ender 3 Pro. You can use any version of the Ender 3. That model with the Pro and the V2 and all that. You can use any version of that. Motherboard. I think you can even build it with the original motherboard, but you can choose. I choose to go with the Octopus V1.1. And you can use all of the stepper motors that came, the steppers that came in the Ender 3 to create it. And me, Mr. Spending the money to get it done, I end up buying new stepper motors and want to be fancy, you know, or whatever. So, you know, I end up buying new stepper motors. Some of them I use from the Ender 3. I think the 4240 I use from the Ender 3 on the Z-axis. The what was I about to say? I was talking to T. If you're listening, T, in order to go in spread cycle mode, all I have to do is comment out the stealth chop threshold, if I'm not mistaken, right? It's 999. Let's see. Oh man, I got two different keyboards, people. I'm typing on the wrong one. And that gives up. I look at the keyboard when I type. I've never been good at typing. Settings. Let's take a look at it. By default, Klipper places the TMC driver in spread cycle mode. If the driver supports stealth chop, then it can be enabled by adding stealth chop threshold to TMC config section. Spread cycle mode provides greater torque and greater positional accuracy than stealth chop mode. There you go, T. However, stealth chop mode may produce significantly lower audible noise on some printers. Test comparing modes have shown an increased position lag of 75% of a full step during constant velocity moves when using stealth chop mode, for example, on a printer with 40mm rotation distance and 200 steps per rotation. I think that is my motor too as well. But however, this delay is obtaining the requested position may not manifest as a significant print defect, and one may prefer the quieter behavior of stealth chop mode. It's recommended to always use spread cycle mode by not specifying stealth chop threshold, or to always use stealth chop mode by setting stealth chop threshold to 99999. Form tuning drivers often produce poor and confusing results if the mode changes while the motor is at a non-zero velocity. So if the motor's not moving and you change it, it can mess up your results, is what it's saying. It looks like, that's what I'm saying, it looks like if I comment out the stealth chop threshold inside of the extruder, it should go back in the spread cycle. But it says, like what you just said, it says it is recommended to always use spread cycle mode by not specifying stealth chop threshold, or to always use stealth chop mode by setting stealth chop threshold to 99999. Okay, so I'm gonna comment out and that could be it. That very much could be it. Yeah, I know. I'm not gonna, it won't allow me to save it. It'll allow me to save it, but it won't change it. Because it was at 0, is what you're saying. And one thing, it's recommended to always use spread cycle mode by not specifying stealth chop threshold. Yeah, it was at 0 already. All right, so no solve to that. I was praying that was it. Let's take a look. It definitely looks like I have some layer artifacts. take a look. I don't know if you can see. The mic going a little bit. You take a look. I don't know if you can see the. I definitely still have some retraction bits in there, which, you know, I can run a retraction test. I don't think it's the retraction distance. I actually think it's the speed. The speed needs to be slowed down some. So it looks like looking at 225. 225 looks like the best print, but if I'll show you guys once it's done. It looks like it may be retracted too much. That retracting distance could be a bit much. I'll show you on the end because you can't see it. You're looking at straight ahead. On the side of where the little circle with the point in it has, there's a hole on the side. I don't know if the retraction is too much, but it looks like, you know, it has some stringing, which looks like it may be retraction, but 225 has the sharpest point right there. Yeah, that's what I said. I had to turn I had to turn down the threshold of the beacon probe because it makes so much noise, it was causing a beacon probe to, I guess, feel the vibration, and it was getting, you know, inconsistent Z offsets. So I didn't run the input shaping test yet, but after I ran it and then, you know, set the tolerance level, it basically contacts the way it's supposed to now. The retraction speed is 35. It's 35 millimeters per second. Let me go into this. The retraction speed is 35 millimeters per second retraction, and the detraction is 30. So I think I'm gonna turn those up. I think I'm gonna make it a bit slower with the retraction speeds and cut the length down some. What you think? Or I'm gonna just run a retraction test. Yeah, that could be confusing. That is, it's running back faster but going back slower. Would you do like 20 seconds? That's what I think I'm going to do. I'm not going to do a retraction length test. I'm going to do the speed first. I think the speed may take care of it. I have ran retraction calibrations on here, and it, you know, it's not making any difference. I think I need to test the speed. Yeah, I think you're right about that. That is the heat creep. The fan is definitely on. The fan is definitely pushing air. But yeah, I think it needs to be open a bit more, or some type of ventilation in the front rather than coming from the tops and the bottom. Yeah, I think I'm gonna do the speeds. I ran a test on the length. Like I said, I really didn't see any difference. I think I may go with the speeds. Go back to it. See what we got going on. Right now it's at 210. It's got a few more layers to go. I honestly might stop it if let me take a look at that. $210 actually looks kind of good. It's maybe I need to change my retraction settings, because I'm looking at it from the perspective of, okay, I'm using the K1 settings, so it should be the same thing as the K1, but that nozzle could be running hotter than the K1's nozzle. There's less stringing at 210. The point on that, the triangle just doesn't, or the point on the cone coming up in the middle just doesn't look good. It looks like it's too choppy, and it could be the retraction with that. See right there, if you guys look on the back end, that's where it looks like it doesn't respect the overhang, and it could be something that, like right there, it look like it could be something in the slicer. And you can see once I take it off of here, and you can see on the back ends, the layer lines just don't look good. Now I made some adjustments to the pressure advance. It's pulling through the vent hole. It's pulling through. It's supposed to be cooling down the heat sink, if I'm not mistaken, right? But it's an ugly print, you know. It's not really printing at super high speed, so 205 looks better than 230. And if I am going to be using it to print, I might have to drop the speed that it prints at to about 205. Could be the air too much air, especially when, you know, it printing very slow. It could not be letting the layers attach to each other. Might have to turn that down. I'm gonna have to turn down my cooling. See, I'm here on this Discord right now. It's like no print. People just talking about printing ASA, which is they're printing at pretty lower temperatures, which means it's kind of, this thing doesn't high temp print like how the K1 does. Or the X1C. Honestly, if I'm gonna print at 230, I gotta print faster. Got the fans to do it. What layer is that on? Alright, it's at 195. Looks pretty good. 10 looks even better. Okay. Yeah, I'm gonna mess with the retraction speeds. So I tripped over the wire. That's what happened in there. I tripped over the wire. This right here is what printed. I'm looking at it. I printed this the other day, so it's kind of tough for me, I guess, because it looks like it can handle 230, especially with the dual fans. 225, it looks like a good cone. All right, so 225 looks like a good cone. Knock down something. All right, sorry about that. Me looking at the Temp towers, I got a lot of stringing in 225 and 230, and what it does look like, it looks like I am getting drip from the nozzle that's creating a bad print. So it could be heat creep into the actual heat sink. I don't know, that's not, it's going a little too slow right there. It looks like about 215 is where there's a, with the pressure advance that it has in it, 215 will be the good marker. Hold on, let me see. Let me go back to the other camera. I'm not gonna mess with this camera. I'm gonna go back in the shop. Give me 1 second. Hold on, let me see. Turn the temp way down. Yeah, the sensor type. Why? See it for the heat bed. Where's my hot end sensor type? Oh. Ah, it's a generic. Oh. It could be that. Yeah, I see it's generic. I never said it. Thermostat. I gotta find it for the hot end that I'm using. Give me 1 second. Yeah, no, it has a generic. Yeah, I never said it. I gotta remember what this hot end. Having some internet issues right now. Close this. All right, let me not go here. I'm sorry, y'all. You have to see me for a second. That could very much be it. Yep. I'm sorry about that. Sorry about that. Yeah, the conversion was around. Sorry about that. The conversion was around $500 to $600, and that's me including the Ender 3 that I brought for $80. So if you already got one, it'll be somewhere in the range of $400 to $500 for you. Sorry about that, man. I'm just in here trying to go back and forth. So let me see. Give me information. Somebody did ask that question, but where's the answer to it? Yeah, that's the one, T. You know off the top of your head what type of thermistor it is? Common temperature measurement. Maybe the same as any see it in there. Description specifications. But on the specs it doesn't. Might have to find it somewhere else. This isn't. I mean, I'm just looking for the perspective of. Maybe it's the same. Wait. That's why I use brand. TZ. Let me see. TZ 3.0. pop up. This same type. Look, and ran through this whole thing, totally forgot about it. See NTC 3950. Where'd you see that at? Yeah, it's 24 volt. No. That looks very familiar, actually. NTC 3950. Hope that's it. And that could very much be what's going on with it. What I'm looking for is how the, because it's saying NTC. I don't know exactly how I have to put it in here. Klipper. This is how I do my research. I'm sorry, y'all. Change your battery extrusion. Back in November, there was an update that introduced a new sensor type called generic 3950, and it's probably going to be more accurate than any other sensor types if you're still using a stock thermistor or have upgraded to a no-name cartridge thermistor. Just change your bed and extruder section as sensor type generic 3950 to make the switch. So if that's the case, that's your work. Guidelines for installing. Yeah, then if that's the case, because it's generic 3950 in there, right? thermistor. Ah. Extruder. PID. This isn't my PID. That's for the bed. That should be on, right? Control PID. And it should get the PID from here. Let me close that. Yeah, let me do a... Alright, let's do that then. Alright. So you saying started hey Tinkerwell. So started the 230 and just change it. Yeah, I tripped over the cord and turned it off. Alright, let me slice this. Matter of fact, hold on, let me not slice that yet. Let me change something. go in here. Hold on. Let me make sure my mic is on too. Yep. So, all right. So you're saying start 180. All right, so these are 180. All right. So start at 180, then. Got you. coming out. It's coming out thicker. Yeah, it's printing. It's not as hot, but it's still hot. So you think it's running too hot. It doesn't look bad. It's still leaking though. It's still dripping. So it's running way too hot. If you can see it from there, I didn't change any temperatures yet, and it still has stringing from like it's dripping too hot. Yeah, it's at 180. It's definitely at 180. You can see it's still stringing too, so. Let me go take a look, I'll be right back. Yeah, the layers do look cleaner. It's just massive stringing. The bottom layer is rough because it wasn't hot enough. First layer 200, rest at 170. Let's do that. Sorry if the screen keeps flickering. Roger. Yeah, I think so too. Yeah. All right. So right now we got yeah. I think it's running hot, and I honestly think, when I got this off-brand kind of TZ hot end. The thermistor may be different on it, but it's about to start now. I actually think it is going to print. And that stringing is maybe heat creep. The nozzle is, it goes all the way up the actual heat sink. It's one of the nozzles that you're able to replace while it's cold. See, the aux fan is not valid. The aux fan. Saying that again. Aux fan, not valid fan. It says that from time to time. And that's probably what they did. They probably put the wrong thermistor in it. So now it's going up to 200. Should print this first layer. Let me go in here. Having technical difficulties all over the place. Sorry about that. My mixer was off over here. But no, I think T, I think you solved my issue if you're still watching. I'm sorry for anybody who couldn't hear me in here. I think it is the hot end. I think it's the thermistor on the hot end. Like I was showing in the video earlier. I'm just going to replace it with this Bamboo Lab hot end. Because right now, even it's sitting here waiting to get to 200 degrees Celsius. See, it's still hovering. That's what I was saying before. It's still hovering above there. It's right at 200, but it hasn't moved. It never does it with the hot bed, but it only does it when the nozzle heats and waits. So what I'm gonna do is I'm gonna cancel this print if it allows me to. I might have to force it. Yeah, I might have to force it. Stop that. Make sure this is clean. And when I take it off, I'm gonna see what's the thermistor that's on it. See if I can see it now. Not that hot now. Sorry, if y'all see my head. Man, yeah, I can't tell what's on it. Yeah, I'm gonna see what's going on with that. It's definitely PID. It seems like in order for me to PID tune it, I gotta PID tune it to a specific temperature. But yeah, I definitely think it's the nozzle. I'm gonna probably have to change that, or see what type of thermostat they actually put on it. I think I'll have a better experience with the Bamboo Lab one. Yep, the hot fan is on. I'll go back in there if this thing eventually starts printing. I just set it to go again. Hopefully it does this time. That was the first time it waited that long for me though. I don't know if it's the actual test or what. And like I said, it's yeah, I think I'm gonna do that. I'm gonna PID tune it. There's a tune I have because I got a bunch of different ones. Let me see. See, I have tunes for different PLA, but there's one in my other printers that seem to work better. And I really think I'm just having an issue like with this nozzle cooperating, the thermostat cooperating. I think that's my issue. definitely these same wires, so it's a 95. Ooh. Yeah, this thing isn't going to start. All right, all right. I'm gonna end this. Stop this right here. So, looks like we're having some technical issues with the hot end. Definitely look like we're having some issues with the hot end. See if I can do a whole round. Klipper. Tune it up to 200. See if it works after that. Back in here, this is at 61. So right now it's tuning up to 200. So that's done. that saves. I'll put the heat pad back up to 50. Let me go clean the nozzle off, because once it does its beacon contact, if it's filament on the nozzle, it'll be an off reading. See if it works. All right, everybody, here goes nothing. This lady's gonna do the same thing. The best I could probably try and do is re-slice it. Get in here. Faith you was gonna work this time, man. While I'm reslicing it, I'll let it continue. Maybe it'll start. Just to get this just to get this print to restart, I'm gonna take it off of print and wait and just let it run through. Three. Save that one. Cancel. This file. Let me stop this. Reset the firmware. No files. All right, there we go. All right, I'm gonna go back in here, take a look at it. This time it's gonna blow right past heat up and wait. All right, what happened was it went below my threshold. Yeah, I'll show you the PID value. Can you see it? All right. 834. These are in here. I'm gonna just delete these. These were from something else. Save, start. Oh no, it's the heat bed. I'm sorry. What's up, Bob? Let me go clean the build plate off. And I'll get this started. Let me get this back up to 50 so I won't have to wait for that. not going to print. It's not going to be high enough in tone. Yeah. Alright, let me use the other one. PID's back. It's a weirded out PID by it. Yeah, it's raising up. Let me stop this. Yeah, it was jumping all over the place. Take. Yeah, that was jumping up all over the place. The tune itself was off. Yeah, I'm using the main board for the hot end. Yeah, I'm not using a MOSFET for it. Let me see, let me retune this and see what it gives me. So I'm gonna save this config and take a look at it. Yeah, it dropped it down low again. All right, I gotta look more into this. Well, like I said, I might just change the hot end out and put that Bamboo Lab hot end in there. Yeah, I do. I just gotta change the right now it's one of those small GST connections on there. I just gotta change it to a one that fits the connection. Yeah, because it could be the motherboard as well. All right. All right, so I got to get back to some constructive maintenance to this, and I'll test it out. But it's a ride on this one, man. Appreciate it. We're gonna wrap it up. I got some other things I got to do. I got to make some runs. Thank you so much for tuning in, T. Thank you so much for the help. Definitely gave me a direction to go into. If and Bob, I'm definitely gonna connect that Bamboo Lab one and see what type of response I'm getting. If I'm getting the same, then I know it's the motherboard. If not, then I know it's the hot end or the thermistor. So appreciate it, people. Thank you for taking this time and this path with me. I know we didn't accomplish much. At least the ender is running now. So, all right. I'll see you guys on the next one. Honestly, it'll be next week. Probably, if not Thursday, definitely Friday next week. We'll be live and running the calibrations again. But I got some tinkering to do. All right. See you in the next video. Hit me up. info@jadovishop.com to if you got any information for me, if you want to sling some thoughts around. All right, till next time, see you in the next video.